Okay, hi everyone. Thank you so much for coming. My name is Amal. I'm a senior open web engineer at Boku, and today we're going to be talking about how you can leverage ASTs to really push your code forward, and really why it's important to master this skill and just kind of be able to implement that in your teams. So a little bit about me. Like I said, I'm a senior open web engineer at Boku. Boku's a really interesting company because it kind of founded from the jQuery core team almost a decade ago. And Boku was founded during the browser DOM war, in that kind of era while it was ending. We're kind of really experts at web interoperability. And so we got involved with building web apps for a lot of interesting, pretty large companies. And our expertise for building on the platform has kind of taken us into the standards world. And so we're really heavily involved with web standards now, and we work a lot on interoperability testing, and conformance testing for both JavaScript, the language, as well as web APIs. I love unit testing and infrastructure. That's why I also work at Boku. I'm a co-host for the Web Platform podcast. I'm also the organizer for the Cambridge Google Developer Group, and I live and work in Boston, the best city in North America. Maybe after Vancouver and New York now. So the open web is really the greatest thing that we've ever created. It's humanity's greatest achievement to some degree, and the rapid change of innovation that the web has brought into our lives has come with a cost sometimes, and as developers, some of the costs that we've incurred is the fact that we're currently architecting for, hardwired devices that, have beefy specs, and we're not really good at these little mobile devices, right? So if you have a desktop device that's hardwired and is not using Wi-Fi, you're going to have a pretty good internet experience. But for myself, I live in a city. I'm an urban commuter. My web experience is pretty shitty most of the time on my phone. And so, so we have this awesome evolution, great, yay, change, fun, pushing stuff forward. And in early 2014, we kind of hit this really interesting tipping point where, more people were accessing the web from mobile devices than desktops, and that number is just skyrocketed since. And with that comes this, kind of big delay in how we structure our applications and think about what we're doing when we're, shipping lots and lots of bytes over the air. The average, this is actually from HTTP Archive. How many of you are familiar with HTTP Archive or know what it is? Awesome. So for those of you who are not familiar, it's this awesome project that basically uses bots to scrape the web and gather metrics on web usage, how many people are using promises in their code, how long does it take an average website to load. So I would highly advise you to check it out. But this is from HTTP Archive. And the average, site is, shipping around 400 kilobytes, and on mobile, that's, an average mobile device that's up to 15 seconds to load. So that's no joke for time to interactive, for those of you who are reading my bad pun. And so just a quick health check. How many of you are, I won't tell your teammates or your bosses, or maybe we do this anonymously, everybody close their eyes. Actually, let's do this anonymously. Close your eyes, everyone, and raise your hand if you're happy, or nod, raise whatever you're comfortable with. Make a motion if you're happy with the state of your code base. All right, so I'm seeing like 25%. So that's awesome. I mean, it's great. I think the 25% of you that are like happy should like all be speakers next year and tell us like what you're doing right. But you know, this state of JavaScript as a whole is in a very kind of dicey situation. I do a lot of mentoring, as you saw from like my community involvement, and I meet engineers that are coming into the field all the time that are just like, wow, this is just so intimidating, you know, and they're not all, you know, new programmers. These are you know, folks with, you know, 10 years of experience writing PHP, you know, that just find the JavaScript world really fatiguing, and just, you know, there's just so much change, and you know, and I think a lot of that churn, you know, is mostly for good. You know, I think we're definitely shifting towards good paradigms and architectures, but it's also really exhausting, and I think that's like totally fine for us to acknowledge that, and it's like really healthy to say like, I have JavaScript fatigue, like that's okay. And so I'm a stickler for unit tests and you know, really writing maintainable code. And you know, we're consultants at Boku. You know, I always kind of try to advocate whenever I have the ear of like a product owner or a tech lead or an architect. You know, please stop like only working on new features. You know, once you ship your code and it's like left your machine and it's you know, on production, it's kind of officially legacy code, right? So you're always paying rent on your code. And so, you know, if you don't pay your rent, eventually it'll catch up with you, right? And so tech debt is this thing that's like totally normal, and it's just a natural byproduct of writing for the web and writing software that, you know, rapidly changes. But we need to kind of pay that down, right? And so, so as engineers, you know, we have a voice too, and actually we should have the strongest voice. And so, and if you don't feel that way, come talk to me, and I'll teach you how to talk to your you know, non-technical stakeholders. But a lot of the problems that we're facing. Are just, you know, just code cruft, right? Just things that, you know, multi-person, multi-year like projects are, you know, without strong conventions, you know, are gonna have some cruft, and that's like totally normal. You know, no one should be ashamed of, you know, the fact that they, you know, have an application with maybe 3 languages, and like, you know, you're, you know, running a really old version of, I don't know, Backbone on your client. Like, there's nothing wrong with that. Real applications have cruft. It's just, it's a consequence of like being alive, right? So embrace the cruft, but plan how you pay down that tech debt. And so we're dealing with a lot of aging and shifting dependencies, right? So NPM, like it's like our favorite, like my favorite thing to do, like NPM install like whatever I want. But the reality is every time you import a package, like, you know, you're kind of like married to it forever, right? And so, and it's not just external dependencies, it's internal ones too. There's legacy APIs that other teams are deprecating. There's lots of, you know, kind of change in within your code internally as well. And that's very true for enterprise. How many of you have heard the joke, tell me how many modules you have and I will tell you how many teams you have? You know, like it's basically, you know, depending on how engineering teams are structured to work together, they're gonna collaborate or compete, right? And it's just like natural dynamics that form. And so, and then insufficient unit test coverage and integration test really kind of makes any type of refactoring effort that you want to do very scary, you know, and hard to kind of advocate for. You know, so I personally think that, you know, when you're doing a refactor, like if you don't have unit tests for the code that you're trying to refactor, you shouldn't even, like, you know, you should first write the tests and then say, okay, now time to refactor. You know, but that's just, you know, my opinion. So maintaining a large code base well, you know, means that there's going to be constant iteration. You need to monitor the health of your code, and you need to kind of constantly be refactoring and finding opportunities to make your code more consumable and so that future you is going to be less frustrated. And so it doesn't help that we have like I said, dependencies that are pretty deep and with we didn't have a lot of thought about how we the front end community basically took over NPM. I don't know if everybody is aware of that, but the Node community basically was doing their thing, and NPM made a lot of sense for Node, and React came along, and other libraries came along, figured out how to get the modules to deployments wired in, and then NPM usage just kind of skyrocketed. So for better or worse, this is where we are. And a lot of your tech debt sometimes has to do with, I'm stuck on a really old version of Lodash, and Lodash is deprecated Pluck, and I use Pluck everywhere, and so how do I safely do this? I may not have test coverage. We're indefinitely stuck. And the really kind of dangerous thing about dependencies that are you have one package that's holding you back. There's this thing called peer dependencies. How many of you are familiar with it? You might have seen some errors in your terminal. Awesome. So peer dependencies are, it's a way for library authors to say, hey, version 1 of this package needs, version 3 of that package, installed. And if it's anything more or less, I can't guarantee that things are going to work, which means that everything is kind of, it has this ripple effect on literally holding you back as you kind of cascade throughout your dependency tree. So it's something that I'm interested in actually really advocating for over the next year. So you might see some Medium blog posts, clickbaity titles. But this is something we really need to start talking about as a community, and just kind of promoting more mindfulness about when we're adding a new dependency, let's make sure that we really need it, and let's make sure that if we're going to take on this burden, we're doing the appropriate kind of auditing and decision making around vetting the dependency, right? So like I said, we pay rent on all of this, and so how do we manage these changes? It's super, super overwhelming, right? And so a common approach for this is Regex. And so, and looking at my slides today, I think I've said the word Regex too many times. I think I have a quota of maybe 3 more times today. So I'm going to try to be really sparing with it. But Regex really makes my head hurt. And whenever I have to write a complex regex, I'm always in Rubular or regex helper, depending on what language it's being run in, what execution context it's being run in. But it's complex stuff, and even people that are really good at regex can never confidently say 100% that there's no edge case that they're missing, And that's kind of scary, right? Regex is a great technology, but it's regular expressions, which means it's kind of just in JavaScript dynamic regular expressions. Do you see the conflict here? So refactoring with regex is kind of like this, it's is it working? Oh no, it's broken, and inherently some of us might not be using regex, but we're using maybe find and replace via our IDEs, which under the hood are using regex, right? And so whether you're using it directly or indirectly, you're using it. And so it's not good enough. And why? I have a pretty long soliloquy on this. I will try to summarize it for you. With the dynamic nature of JavaScript, when you're trying to use Regex to help refactor or find patterns in your code, you're inherently missing a lot of things because, for example, modules, right? Import foo, as star, or you can dynamically rename things, right? You can reassign things, and because it's not a statically typed language, it's not like, it's never foolproof, right? So inherently, Regex is just kind of flawed, and it's not a solution for us moving forward long term. So I don't know, like if only there was like some technology that, we could use to like maybe solve this problem. I wonder what, and spoiler alert, because it's, I don't know, maybe in the talk title. But we're gonna just switch gears here. Hopefully this works. Can everybody see? Oh, it's like tiny, right? All right. Can everybody see both sides clearly? Yeah, and for folks in the back, like you should, don't feel feel free to come up at any point. And so the tool that we're looking at here is called AST Explorer. And I'm going to formally define ASTs in just a second. But at first, for those of you who maybe haven't been exposed to it directly, you're all using ASTs every time you write code or interact with any software. And we'll get into that in just a second. But this is a tool that it's an open source tool that basically allows you to explore the AST structure for any piece of code. And we'll get into some of the other features, but let's just start with a very basic hello node. Capitalize node.js interactive. All right, so we've now written some JavaScript on the left, and you can see here we now have this tree that's popping up. And so program is so this is a tree that's right now using a parser called Acorn. If we want to use, Babel parser or another parser, we can. And there's very subtle differences between the structures that they output, but they have core things that are the same. And so file is literally the context that it's running in. That's program. There's always a body. And if I had a comment block above here, hello comments, we would, depending on what, different ASTs, different parsers kind of output comments in different places, but you would see that, comment is outside of body here. And so inside of body, we have a variable declaration, and that's basically what we're looking at with, the token const. And in here is, some very verbose but very awesome consistent programmatic data structure for basically taking your code and parsing it into a format that is prepping it for a compiler to ingest. And so I'm sorry that this isn't the best interface to kind of it's not a very good demoable interface, but I encourage you to either code along or try to do this at home. But getting back to our slides. So an abstract syntax tree, the official kind of, the Wikipedia official definition is in computer science, an AST is just a tree representation of the syntactical source code, right? So like I said, it's the representation of your code for the compiler. That's like the Cliff Note version, and that's all it really matters for your context. So some of the things I hope to kind of dive in is, what are these things? How are they used? Why should you learn them? And how are they really helpful in refactoring? And obviously prove that they're way better than Regex. So I know I dropped the word compilers at a JavaScript conference, and you guys actually you're a pretty mellow crowd. So I don't know if it's because compilers don't intimidate you, but they intimidate me. and it's definitely not something that I ever thought that I would get closer to. Given that a lot of my experience is in kind of higher level or dynamically typed languages. And so I promise you it's not scary, because the only parts that we really care about are these initial bits. And so this is kind of a very simplified kind of a flow diagram for how your high-level code gets translated down into machine assembly. And so the first step is it goes through a lexer, which takes the tokens that we saw. So const every piece of every line, every item in our code kind of it translates to a token, whether it's a string or a symbol, And so once those tokens get generated, those tokens then run through a syntax parser, which generates the abstract syntax tree. And so that's the tree that gets fed into subsequent bits, which I won't spend too much time on, but our work kind of ends here. And so here's an example from Franziska. She's actually another speaker here at the conference. She wrote a really great article on some V8 internals last year, and so every single JavaScript runtime, V8, JavaScript Core, Chakra, I'm missing one, SpiderMonkey. There's more. Those are the major ones. They all kind of really have the same structure, and they all do the same thing. They have different implementation details and different kind of performance optimizations and caching strategies. And so, and up to kind of this step here, it's really all the same flow. They might just have a different syntax for the abstract syntax tree that they output. And so, looking at our code here, this is actually a little bit easier to I think, see than that interface that we saw. Our variable declaration on the left, as you can see, these little pop-up items are tokens. And so this is step 1 on the left, step 2 on the right. And so these tokens are what is used to generate the actual tree, and the tree has a very predictable structure, and depending on what parser you're using, there might be slight differences in terms of additional items, but the core is always the same. And so it makes understanding your code really, really predictable, and there's no guesswork, right? So if you want to find a specific item, in your code base, where you want it to be a variable that has this value, or you want you're looking for functions that have these contents, you can actually query it almost like a database. How many of you guys are using GraphQL? Yeah, so maybe you can make a AST GraphQL project. That would be really fun. So ASTs are actually the underlying technology of a lot of the build tools that we already use. So how many of you are using things like ESLint, Babel, right? Prettier, any code coverage tools, static security, analysis tools, anything that tells you something about your code is using an AST, because I can tell you they're not writing a bunch of custom regex for your code, right? So they're using ASTs to kind of create this predictable data structure that they can then confidently analyze. And so Babel is, just for those of you who may not be familiar, it's a JavaScript compiler. It's actually really a project that has revolutionized the way most of us are coding these days, because it allowed us to kind of get ahead of the browsers and not have to wait for features to be implemented, right? So it takes JavaScript as a source and outputs JavaScript as a source, and everything in between is transformed via different plugins. And so if you're writing a bunch of newer JavaScript and you wanted to transpile it down to something that is kind of compatible with all browsers, then that's the tool that you would use, Babel or Tracer back in the day, which is now deprecated. And so I just want to make a quick plug for Babel here. It's like a community-run project. It's like not funded by a company, which is like very common perception. So a few of us here are friends with Henry, and who's one of the maintainers, and who's really trying to educate people that, hey, actually we all work on this for free, and so if your companies are interested in contributing to open source, this is a really impactful project that is really, I think, a historical one, so consider donating to Babel. But let's just take a minute to destructure how Babel works. And so there's kind of three core architectures here. So once we input code, it gets parsed, right? So a tree gets output. And then in here is, in this transform section in the middle, that's kind of like where the magic happens. So if you have different plugins, if you have your own custom plugins, this is where they're getting run. This is where they're getting executed. And there's some interesting gotchas with Babel if you're writing a lot of your custom plugins, because all the traversing of the tree is kind of happening in the same context, so you have to be really careful you're not overriding something that you weren't expecting to be there. So, so once you parse your code, you get your tree, you run your transformations, right? So at this point in the center, we're in abstract syntax tree land. We use the tree to find patterns, and then we use builders to say, hey, okay, I want to change it to this thing, and then we output a new tree, and then we basically reverse engineer that process and take that tree and spit it back to code. And that's basically how Babel works. And the same kind of architecture is, actually I'll go back. And the same architecture here is what you would use to write your own custom code transformation. And so Babel isn't really a project that most people consider using when they're interested in writing some type of modification to their code base. Recast is really kind of the thing that's really popular for that. JS Code Shift, which is Facebook's wrapper around Recast, which adds a lot of really nice APIs, is that. But there is actually a project called Babel Code Mod, and I found it while doing research for this talk. And you can basically leverage Babel to do that same thing if you're interested in doing that. And so Babel actually on its own doesn't do anything, literally, if you just don't have any plugins and you say, Babel, Babel my code. It doesn't actually do anything. It requires plugins to work. And so the plugin ecosystem is how Babel kind of has been architected. It's a very pluggable, scalable architecture, and I'm actually really glad for it because I don't know whose decision it was to make that a thing, but Webpack kind of is on that bandwagon. ESLint is on that bandwagon. So we're seeing some of our build tools kind of stabilize, right? So which is good for us. Babel's been around for a while. I don't see it going anywhere. Same with our ESLint or Webpack. And so this Babel plugin is actually really interesting because it's a lot different than I think what you guys are maybe used to seeing Babel used for. So this is a plugin that basically pre-evaluates your code. Can you see the code in the back, or yes, no? Okay, let me pull this up on GitHub. Babel PreVal. All right. Cool. Is that better? Yes? Okay, awesome. So this is a really interesting plugin because it solves some really cool problems. In that what if you want your code to be evaluated at runtime, during the transpilation process, right? So it's not the static value, and so what it allows you to do is, say, hey, PreVal, right? And the reason why this is valid JavaScript, without any imports or anything is because this, when you're writing, when you're using a tool like Babel, sometimes you're not writing what's technically JavaScript, right? Because it hasn't maybe made it into the specification yet. And so, Babel has, this Babel plugin extended the token, to be able to, the tokenizer to be able to recognize PreVal, right? And so that's kind of some of the stuff that's happening under the hood. But so PreVal evaluates this thing at build time, and it's able to output that. And so a more interesting example is here, where you're you're fetching something from an API server, right? This is super cool, where you're basically able to ship a different version of your code just because you built it differently and not because you changed the content, And it's not like an API call that you did when you're, running. So this is actually really powerful and kind of genius. And so shout out to the person who created this, can't see Dodds, but it was supposedly, he's and I love that he did this. He's I saw somebody talk about this idea in a GitHub issue, and then I just built it, and he gave shout out to the person that built it, so that was really great. But this is such a cool plugin, and I can see this being really useful. And so this is the kind of stuff that you can do. It gives you power to, change the way you build your code, but even more power in refactoring. So hopefully how are we doing on time? All right, we gotta speed up. Using Chrome, here we go. So just to kind of drive the point home here, when we looked at the list of parsers that were available for JavaScript, so you need a parser, and you can write your own parser. I have lots of friends that are language enthusiasts that can write their own parser. So that's what takes the code, creates the tokens, makes a tree. And then once you have a tree, you need a mechanism for being able to traverse the tree, right? And it's usually some type of breadth first or depth first search. And you traverse the tree, find the nodes that you want, and then once you find the nodes that you are interested in modifying, you can make the change and generate a new version of the tree. And so, your transformer generator takes the new AST and outputs it into new source code. And so this is a good segue into code modifications. So the first time I actually learned about code modifications was through Adi Osmani, and I'm finding it really hard to avoid bringing up Adi Osmani in my talks. I find that I'm always referencing something he did or said. It's this weird, yeah, right? Susan's laughing in the front row. Yeah, it's true. So Adi, love him. He's pretty. I feel like if you just read his blog, you'll be employed forever. You'll know everything that's coming. But in 2014, Adi JS Hint, which was a really awesome lint tool. It's still there. It's not for modern versions of JavaScript. He basically was like, "Hey, I'm gonna, input my source. This is the sorcery that's kind of broken out here." And so, Esprima, which is the project out of jQuery Mozilla. One of the original kind of open source projects around creating ASTs, using Esprima to generate the tree, do that whole flow that we talked about, and then output the clean source code and do what else. So this is this is pretty much the pattern, and also it's not new. And I think a lot of people associate code mods with Facebook, but like Recast is a really old project that I think Facebook kind of made popular with certain communities. So anyway, so now that you know the ABCs of ASTs, which are just awesome, awesome, awesome. There's like no other actual letters. So let's actually, I wanted to do some live coding with you all on this, to do some transformations. All right. So if you guys can still see my screen, yeah. Well, actually, I don't need my console. These were the parsers here. So this one is ESLint, Babel. They all kind of have their own parsers because they have their own kind of sugar on top of things for their own personal workflows. We can just use Recast, which is fine. And so there's this button here for being able to like enable transforms. And so this kind of makes it this interactive. Even more interactive REPL. So you can choose what library or what transform tool you're interested in using in writing things for. ESLint is one, Prettier is another, and we're gonna use JS CodeShift because it's a wrapper around Recast and it has a really nice kind of jQuery-like API, and it's got some really good helpers on it as well. And so, as you can see, as soon as we popped this up, can anyone tell me what's different in our code? It's backwards, right? And so, what's going on here is that, so this is the library. So if you, you can do this right in just a JavaScript file that you have. So file is obviously this top block here. And so we're iterating through any identifiers that we found. And so the best part about this process is like you don't actually need to memorize what any of these tokens mean. You just need to know what you're trying to find and what you want to make it, right? So I don't know. I want to change this into a function. Let's just say, if I wanted to. I don't know what a function looks like, so let's find out. So we have a body here. I'm going to just disable the transform for a second. So we have body, and now we have a second thing that's popped up on our body. So it's a function declaration. So that's a key term that I could use to actually find it. And the identifier, which is the name of the function, is hello. So that's that's good. And that's about it. So all I want is to, actually, we'll have this be return by, since we're almost out of time. Looking at this function declaration, there's a block statement, okay. Let's see, where's the, oh, sorry, inside the body of the block, right? There's a return statement, and then that value is by. Okay, so it looks a lot worse in the tree than it is in the code, I promise. So if we now wanted to say, so what we're doing now is we're finding anything that's an identifier, like anything that has a name, and just reversing the name, which is not what we want to do. And what we want to do is make this function and give it a return value. And looks like we're out of time. Yes? No? It's 4 o'clock. Yeah. I'm sorry, I'm getting like pinged. It would be really similar to this. I don't know if the room is being, do you know if is the room available? Yeah, okay, I can keep going then. All right, All right, so we're not looking for identifiers. We're looking for function statements, so we can be a bit more specific in our search. And so let's do that. I'm going to comment this out. And so let's make this return statement. Or no, function declaration. And so let's just console log this out and see what it what the value is. I'm using Brave for the first time this month. Okay, so, all right. So it found our node, and so now what we want to do is build up. So what we can do is to be quick, we'll take the value of hello and replace it with. I think the quickest thing for us to do, because to avoid like multiple traversals, we'll take the value of hello and we'll make it the function name. So how would I actually access this function name? Let's see. So we have our identifier. And so what we want to do is set the identifier to the value of this other node that the other hello item. So let's do that. Name. I'm sorry, like my screen is really squished. There. I can just give you guys the solution, which I think is maybe more productive, because my screen is pretty squished and like we are pressed for time. So anyways, I'm going to link you to the slides and my solution. I wanted to live code this so that you could go through the discovery phase with me, but I feel really guilty keeping you here too. So anyways, but anyways, I hope you feel a little more empowered about understanding the ecosystem with ASTs, how you can get started playing around with them, and yeah, just look out for a link to my slides, and thank you very much.